Hey everyone, welcome back to the channel. Today we are diving deep into Pandas, one of the most powerful live Python libraries for data manipulation and analysis. I will answer some of the most frequently asked questions about Pandas, from the kind of data it handled to creating plots, combining tables, handling time series, and much more. So stick around because this video will make your Pandas workflow more efficient and fun. Okay, so let's get started. So our first question is what kind of data does Pandas handle? So we already discussed in our last video. Pandas can handle a variety of data types. The first one is a series and the second one is data frame. Series and data frame. So a series is one dimensional labeled array capable of holding any data type like integers, float, strings, or even Python objects. The second one is a data frame. This is the two-dimensional table similar to a spreadsheet or SQL tables with rows and columns. So let's see the example. The first one for the series. So if you open the new file, then import the library. Import pandas as a pd. So I am commenting this because I already imported in the above example. So s equal to pd dot series. The syntax is, now enter the square bracket, 1 2 3 abc. Now enter the decimal value. Now simply print a. Where is the error? Sorry, not a, s. Okay, now the second one is data frame. So declare a variable data curly braces column name square bracket. Now enter the value of the column. Alice, Bob, John. Now age square bracket 20, 26, 30. Now score 85, 90, 91. Okay, data frame equal to pd dot data frame data print df. So whether it's a numerical data, categorical data, time series, or text, pandas make it easy to work with all kind of structured data. Okay, so the second question is how do I read and write tabular data? So one of pandas superpower is its ability to read and write tabular data from multiple formats like CSV, Excel, SQL databases, and JSON. So how to read a CSV file? We already discussed in our last video. Data equal to pd dot read CSV. Enter the file name. Okay, now print data. Country, age, salary, purchased. If you want to show only top 5 rows, then use the head function. If you want to export the data, in the CSV file the updated data. So how we can do this? First, we assign updated data to this variable. Now print the updated data. Okay, it's working fine. Now export the file, export data to a new file. So again use data, sorry, data dot to CSV, set the path, updated data dot CSV. Okay, now we check the file. So the file is exported successfully. So whether you are dealing with massive data sets or just cleaning up some tabular data, Pandas makes it super easy to get started. It supports lots of file formats, which is great for data science workflows. Okay, now the third question is how do I select a subset of table? Selecting a subset of rows and columns is fundamental in Pandas. You can use indexing, slicing, or logical conditions to filter data. Filtering by indexing, slicing, and logical conditions. So the first one is selecting a column. So how we can do this? Print our data is data. Now not this one. I'm using this one example. So in our data is df. Df name. Okay, now the second one is filtering rows by condition. filter filtered equal to df square bracket df age greater than 25. Now print TERED show only those data whose age is greater than 25. Okay, now selecting specific rows and column. Subset equal to df dot ilocation iloc. The syntax is, now here we use slicing, and here we are mentioning the column name. The second one is score. Now simply print subset. Okay, now we are getting the error. Sorry, not I, it's yeah, now it's working fine. So with the methods like dot lock and dot iloc, you can target specific parts of your data effortlessly. Okay, so question 4 is how to create plot in Pandas. Pandas has built-in visualization capabilities powered by matplotlib, allowing you to create quick and beautiful plots directly from your data frame. So now we are creating a line plot. Df column name score dot sorry dot plot. Now pass some arguments. What kind of plot? Line, comma. What should be the title of plot? Scores over time. Okay, now here you can see the line plot. Now the second one is a bar plot. So how we make this? Df dot plot, this bracket, on the x-axis name, y-axis equal to score. Now what kind of plot? It's a bar. What should be the title? Score by name. Now run. Now here you can see the title of the bar. Score name, score by name. Alice, Bob, John. Score over time. So these built-in plotting tools are perfect for exploring data quickly. For advanced visualization, you can integrate pandas with libraries like matplotlib or seaborn. Okay, so our fifth question is how to create new columns derived from existing columns. So pandas make it easy to create new columns by performing operation on existing ones. So I am adding a new column in the existing data. So df square brackets new column name adjusted score equal to df score into 1.1. The calculated data will be showed under this column. Now print df. Now here you can see the new column is added. Okay, now modifying a column using a conditional statement. So for this we use df, take the existing column name, create a new column name, pass equal to df, take the existing column name which is score. Now add a condition greater than 50. Now print df. Now here you can see the new column is added which is pass. So you can perform arithmetic, apply functions, or even use conditional logic to transform your data. Okay, so our sixth question is how to calculate summary statistics. So summary statistics help you quickly understand the distribution and nature of the data. Here we perform just a simple basic stats, print df dot describe. Now here you can see the summary of the data. Have count, mean, standard deviation, minimum 25%, 50%, 75% and max. The next one is a custom calculation. You find a mean score. df, take the column name, score dot mean. Now print the data. Sorry, print mean of score is mean score. Now here you can see mean of score is 88.66. Okay, now we count the values. Print df, take the column name which is pass dot value count. It's a built-in functions of the pandas. Now again run. Now here you can see pass have three true values. So from the dot describe method to specific aggregations like mean, pandas has everything you need for statistical analysis. So our seventh question is how to reshape the layout of tables. So reshaping data is easy with pandas using method like pivoting, stacking and unstacking. So the first one is pivoting a data frame. Okay, so declare a variable pivot equal to df dot pivot. Now pass some arguments. It take the first one is columns. I'm using name. What should be in value? Sorry, the value is a score. Now values. Print pivot. Okay, the second one is melting a database, a data frame. Sorry. So declare a variable melted equal to built-in function use melt. Now pass some arguments. Data frame id underscore wheres. Use a column name. Value variables which is age and score. Now melted. These methods help you restructure data into the format you need for analysis or visualization. Okay, our eighth question is how to combine data from multiple tables. So Pandas makes it simple to merge, join and concatenate multiple data sets. Now how to merge two data frames. Merging data frames. Now data 1, add a column name id. Now enter some data 1 2. The second column is name. Enter some name John, Bob. Okay, now data 2, again add id. 1, 2. Now the new column name is score, which is in the second data frame. So we use 85, 90. Okay, so data frame 1 equal to pd dot data frame. Now pass the argument data 1. The second one is df2 equal to df dot data frame data 2. Now create a new variable which is merge equal to pd, use a built-in function of the pd which is merge. Now pass the arguments. The first one is data frame 1, the second one is data frame 2, and the third one is on. Merge on the basis of what? On id. So here we use id. Now print the data. Okay, where we get the error. Okay, here is a pd. Now here you can see the data is merged. Whether you are combining data set horizontally or vertically, Pandas handles it with ease. Okay, our ninth question is how to handle time series data. Pandas provide powerful tools for handling time series data, including date parsing and resampling. So, creating a date time index df date equal to pd dot to date. It's a built-in function of Pandas date time. Now they use square brackets, enter some dates. The second one is 20230102. Okay, now df dot set again index date in place equal to true. Okay, where we get the error df date. Okay, so our data frame has three rows, so that's why 20230103. Okay, now set index df dot set underscore index. Use this bracket date in place equal to true. Now here you can see the date column is the indexed column. Okay, now resampling data. So how we can do this? Declare a variable resampled data equal to df dot score dot resample d dot mean. Now print resampled data. So time series capabilities make Pandas a go-to tool for time-based analysis. Okay, so the last question is how to manipulate textual data. So Pandas offers powerful string manipulation methods for cleaning and transforming textual data. So how to manipulate? the textual data. Okay, df column name equal to df name dot str. Now I'm upper this. Now df new column initial equal to df name dot str 0. Now see the result df. Okay, initial. Okay, I'm using the wrong bracket. It's a square bracket. Now here you can see our name column. All data are in capital format, and the new column is created which is initials and get the first alphabet of the name. So whether it's case conversion, substring extraction, or pattern matching, Pandas has you covered. So and that's it. Uh, and that's wrap on today's Pandas tutorial. We covered everything from handling data to visualizing, reshaping, and combining tables. If you found this video helpful, make sure to like, share, and subscribe to stay updated on more Python and data science tutorials. Drop your questions in the comments, and I will see you in the next video. Thanks for watching.